Good good afternoon, everybody. My name is Alessandro Provaggi. I'm head of the DC Plus technology platform, which is part of European Power, the European Association for District Heating and Cooling, and very happy to be here today online to for the webinar on solar district heating deliverables. You may know that this is part of a European project, a project called SDHp2m. P2M actually means policy to market, because one of the main ideas behind is pushing policies actually to achieve a better penetration of the solar district heating, of solar thermal industry into the district heating and into the heat market in general. So we have with us today a quite nice group of experts, and I will not speak. I will stop speaking because I saw that many of the presentations are very interesting, and I'm let them talk and introduce the project. So the first expert to present is Carlo Winterscheid from Solites, and he will introduce the project, and he will also talk about the market activities in Germany. I'll just want to mention that the project has a life of 3 years, and we actually are currently in the last month of the lifetime of the project. So is this basically the last webinar within the framework of the project, and so therefore we're quite happy to present you with the main outcomes. So Carlo, the floor is yours. Thank you.
Thank you very much, Alessandro, for the introduction. Before we start deep into the project SDHp2m, I want to give you a small introduction to solar district heating, and also how it has been evolving within the last years in Germany, because often the focus is on Denmark in the subject. So we thought today we want to show you a little bit about Germany as well. But before that, I want to give you a short introduction to solar district heating, a very short one. District heating is well known, I think, and it is a wonderful platform to introduce renewable energy sources and energy efficiency technologies into towns in itself, or not only towns, but with the district heating network, we could use, for example, biomass as heat-only plants or as combined heat and power plants, solar thermal collector arrays, as we will talk about it today, geothermal energy or combined heat and power plants, not only from renewables, of course, but also from fossil fuels, which can also help to increase energy efficiency technologies. Furthermore, power to heat from renewable electricity could be implemented, as it is often done already in Denmark. And to use those technology in a feasible and efficient way, often it is required to introduce thermal energy storages as well. Often district heating is connected to big towns, but I want to make you aware that district heating can only be seen, also be seen as a part of a district in a town, not the whole one, but to implement, for example, solar district heating only in one part of the town. Or also a village. In Germany, we have had a few villages this year and the past years that have been introducing solar district heating also, which is quite promising as well. And of course, cities, but you could also think about larger building complexes, which could use large collector arrays, which can also be then connected to the district heating network. So there is a good range of possibilities of applying solar energy in connection to district heating networks. With this picture, you have an example from Denmark, which might already be known. And there are some key points about solar district heating and cooling. The first one is, of course, it is emission-free, and even though you might have some energy for pumping, this is only a very minor part of the energy consumed, so it can be seen as 100% emission-free. It is also a mature and market-available technology. It's been developed since the 1980s, and since then a lot of plants have been built, but that I will show you in a second. And it is available everywhere. From my point of view, I think Denmark is not the sunniest place in Europe, but still they are using it to quite a large extent. So I think that's one promising example how successful solar district heating can be. And the capacity can be up to about 100 megawatt. So it's quite large, and it can supply for towns or districts solar fractions of up to about 50% with some seasonal storages. The costs are rather stable with 30 to 50 euro per megawatt hour. That of course depends also on the funding schemes in different countries, but due to the upfront investment, which can then be discounted on the coming years, it is a very stable and reliable energy source for district heating operators. And with that, with renewables in general and the district heating, there are new opportunities how a district heating network can develop to be feasible in the future as well. If we look at the situation in Europe, we have more than 300 plants with more than 300 kilowatt of thermal power, which corresponds to about 500 square meters of collector area, which supply a total capacity of 1,100 megawatt. And annually, there is a growth of about 30%. And currently, that reaches to about more than 600 gigawatt hours per year, which is quite impressive, I think. But still, there is a lot of possibility for further development. And you can also see that the largest share of plants is currently in Denmark. And as I mentioned, Denmark and Sweden were starting quite early in the 1980s and have developed the subject a lot. But also in Germany and Austria, we are experiencing a lot of development at the moment. And also France and Italy are also evolving a lot, which is quite interesting at the moment. If we look now at Germany, you have the map of Germany with the different federal states and the plants which were in operation in the beginning of this year and the ones which are envisioned to be finished. If you compare it to the size of Denmark, for example, the plants in Germany are not that big, but it's a quite developing market, which is quite interesting to see. So far we have in Senftenberg here in the east of Germany, the currently largest plant with more than 8,000 square meters of collector areas. But we also have plants which are existing for a bit longer time in Kreilsheim, which is a district with more than 7,000 square meters. And quite interesting in this year, we have a few villages like Brecklum in the north, Mengsberg in the center, and Randeck in the south, which are applying solar collector areas now for heating the villages in a sustainable way, which is very interesting and promising, and there is more and more interest growing in the subject. Also for the coming years, we have a range of new upcoming projects, and it's quite interesting to listen to all the towns asking how it can be developed, how the planning takes part, and we are looking forward to have this yellow bubble of the plants in preparation increasing quite steadily. If we look at the plants in Germany, we can see that in 1996, the first research plant in Neckarsulm has been built. Those plants, or the first plants that have been built, were all research plants. And Neckarsulm and Kreilsheim, for example, they also use seasonal storages. And there were research projects also from the EU that have been used in the past to develop this technology also in Germany. But the interesting point is in 2013, with this red line, when the first small plant has been built, which was not a research project anymore, but only due to steady costs and the interest in renewable energy usage and the advantages of solar district heating as well. This plant I'm talking about from 2013 is the plant of Büsingen. Büsingen is in the south of Germany, close to the Lake Constance, and they have about 100 houses or 100 buildings which are heated, and about 1,000 square meters of collector area. The district heating network was built at the same time as the solar heating plant, together with a biomass boiler. And they cover about, or the solar heating plant covers about 13% of the energy demand of the village. And the advantage is also that during the summertime, the collector field supplies the village completely. That means that the operators are flexible to do their maintenance on the biomass boiler. The plant itself is operated by Solar Complex, which is a local energy supplier, and they're developing a lot of those district heating systems, but also solar district heating systems more and more in the southern region of Germany. This year, the plant of Wandeck, for example, has been opened as well, which uses a district heating system in a village which has been used for several years. And they also have an industrial customer. And this year they finally decided to build 2,400 square meters of collector area for supplying the industry in the village or the plant, but also the demand by the citizens. When we look at the sector of villages, there are some quite interesting examples of different communities or stakeholders which use this technology. And Hallandorf, for example, a green energy supplier, is using it, whereas in Neuerkirch-Kuels, two villages next to each other have decided to use the solar district heating plant together to supply both of the villages with renewable heat. In Liggeringen, again close to Lake Constance, a local utility has decided to build such a plant. And in Mengsberg, in the center, it's a citizen cooperative which has been developing this plant. In the end, it's those plants are rather small, but it's a quite interesting way of developing the technology. And in the end, there are a lot of villages all over Germany which could apply the technology in a similar way. If we come back to the graph we had before, we can see 2013 we had the first yellow little part here from Büsingen, but in 2016 we have Senftenberg, the first urban district heating plant, which is using solar district heating really for the whole city and not only a district, which is quite interesting. And as I mentioned before also, we have the different villages, so the part we're expecting to grow for the villages quite mentionable, but also for the bigger district heating plants in Germany for cities that will be developing quite a bit in the next years. Now that we talked about the villages, I want to mention also the plant of Senftenberg, which is an urban district heating plant. As I mentioned, it is the largest plant we have so far in Germany, with more than 8,000 square meters of evacuated tube collectors, and they supply temperatures of up to 105 degrees Celsius. It is actually placed on an old landfill area, which was very accessible, and as the ground is not perforated too much, there were no big problems in placing the collector area in that place, because often the challenge is to find suitable land, especially when it comes to more urban areas where the price for land is higher. Then in Berlin this year we had the first urban district heating plant, and the capital of Germany, which has been built together with Vattenfall or by Vattenfall. It has a collector area of about 1,000 square meters of flat plate collectors, and it's quite interesting because in Berlin the decision was to divest from coal usage by 2030, which means that by 2030 they will have to supply about 600 gigawatt hours of heat in a different way in the future. So Vattenfall and the Senate of Berlin, they are performing a study to find suitable areas how solar district heating could be applied in a larger scale. Just to remind you of the numbers, earlier I said we have more than 600 gigawatt hours of solar heat all over Europe, which is supplied currently. And now we're talking about Berlin, which needs to produce 600 gigawatt hours of heat in the future from other energy sources than coal. So it's quite a large scale of energy they need them. Switching now from the big towns to another system, which is in the decentralized feed in urban areas. So this example is from Dusseldorf. There they've got a plant on a building complex, and in a research project they're evaluating how the feed-in process for the surplus heat from the building complex can be used for the district heating system. In Berlin Adlershof, they are trying out a similar concept with 5 different buildings, which have where 2 buildings use solar thermal collectors and also feed in the surplus heat to the district heating grid. When we look at Germany, currently we have the project Solnet 4.0, which is a quite interesting project because on the one hand we work together with collector producers, but on the other hand we have a journalist and the project group from Energiekommune, which tries to push the project also to a more to the audience, to the public, to have more dissemination for everyone and to explain the subject better, to have more plants in the future. And then furthermore, this year we've also developed the webpage of solar district heating, which can be interesting for all of you when it comes to the news. We have different languages from from all the partners of the solar SDHp2m project. We have the news, we have market studies, a plant database, and a lot of guides which have also, or guidelines, which have also been developed within the project. So I want to encourage you to have a look at the recent deliverables within this project, which are quite interesting and promising for everyone, I think. And yes, finally, this was about solar district heating in Germany. And thank you for your attention.
Thank you very much, Carlo. I remind you that this is, of course, a webinar open to questions, so don't hesitate to type the questions, and then I will read them out loud. There is, for the moment, a comment from Savo Solar on that they have additional pictures and videos. You can email them. Apart from that, if there are questions, please don't hesitate to write them also in the coming 10 minutes, even if it's on the presentation of Carlo. But if they are not, I think I'll move to the next speaker, who is Moritz Schubert from Solid, and that will speak about the current situations in Austria. And de facto, he will share the presentation with Karina Seidnitzer-Gallien from IAINTech. And I understand that Moritz will talk more about the big solar project, and Karina more about the overall situations in terms of planning and subsidies in Austria. But Moritz, I'll pass you the floor, and thanks for being with us.
Yes, thank you very much, Alessandro, for the introduction. Yeah, I will have a look a bit further in the future of solar district heating. So we are now doing all the groundwork to make solar district heating more popular, more well-known, to have better boundary conditions for solar district heating. So once this work will be very successful, I will show you what will turn out for the energy supply of Europe. So just a few brief words about Solid. So we are a company working on solar thermal all over the world, solar district heating a lot, but also solar cooling and industrial process heat. And yes, we have all along the equator, we have solar cooling installations and solar district heating, mainly in Europe. So yeah, we started 15 years ago with solar district heating in Graz. Here I show you two of the bigger plants which we have in Graz. So one was commissioned around 10 years ago with 4,000 square meters of collector area, supplying the city with district heating, and another even bigger one at the power plant and on the recycling plant with around 6 megawatt of thermal power, also supplying the city with district heating. So Graz district heating has around 1,200 gigawatt hours per year of heat supply. So what came up in Graz 5 years ago was that the national utility planned to shut down the major plant which supplies Graz with district heating. So the city of Graz urgently needed to look for other sources of heat supply, and this was not only the case in Graz; it was also in other cities that fossil power plants shut down, and that other heat supply needed to be found. For example, in Hamburg, where they have quite ambitious plans, or like Carlo said, in Berlin also. So in Graz, we had a feasibility to look at how can we have high solar shares in district heating. So the major parameters we had to look at are the big bars showing the energy demand, and the green line is the return temperature, and the red line the flow temperature of the district heating over the year. So conventional solar district heating without a seasonal storage is mainly in the month from June to September. You have good solar shares, but in the rest of the year not so much. So if you want to supply also heat between October and May in significant scale, you have to go for solar district heating, including heat storage, what we call big solar. So this is the concept, how it looks like. You harvest the solar heat at the collector field, and from there you either go directly to the grid when there's demand, or you go to heat storage, and then from the heat storage in the winter months you supply the heat also again either directly to the grid, or when the temperature is too low in the is too low in the storage compared to the return temperature, then you use a heat pump in order to lift up this heat. And you can also include then flue gas condensation if you have a biomass or a gas boiler plant at this place. So yeah, here we work together with the Danish consultancy Plan Energy, who's also in the SDHp2m project. And they found out that a technical economical optimum for the city of Graz is to have a solar plant of 450,000 square meters and a seasonal storage of 1.8 million cubic meters. So then this is a green area on the top left, what you see here, and this is when you have the lowest heat generation price, heat production costs. Yeah, and for this you have to invest between 180 to 200 million euros before subsidies. So these are other big plants which are already realized, which have so it's not completely new. It's just adopted to a bigger grid here. What we are planning in Graz, and that is another community in Denmark. They even reach 50% solar coverage because they have lower grid temperatures and other distribution of the heat demand over the year compared to Graz. And in Canada, they even reached 90% already. So what is relevant when you want to implement such a big system? So of course, the temperatures of the district heating network are very important, that they are as low as possible. 50 is good, 45 or 40 is even better, but that's very difficult in a existing grid, for example, in Austria, also in most other towns out of Scandinavia. So it's a competitive heating supply from this big solar. You have comparable economics to coal and natural gas, also to biomass and to waste heat from combined heat and power. The space requirement is quite significant. So, for example, for the Graz plant, you need around 100 hectares to implement it. But normally out of the cities in a few kilometers distance, there are always some areas which can't be used for housing or anything else. Maybe on an old landfill, what we saw from Senftenberg, or water protection area where you can't build houses, but you can build a solar plant. So here it's definitely not so easy. Karina will also show us some issues about this, and but it's always taken into account. So when you integrate the storage and the heat pump to a district heating grid, you also have further advantages, that you have added load due to waste heat, for example, from CHP or industry. You can contribute to peak load, and you can operate a flue gas condensation for heat recovery with the heat pump. Then we had a look how can you apply this big solar concept to which communities in Europe. So we made an estimation that you need a heating grid of about 30 gigawatt hours per year. That's a city of more or less 8,000 inhabitants. So it's a rather, so compared to most of the biomass solutions that we know, for example, in Austria, it's a rather bigger grid. Many of the biomass solutions are in the range between 2 and 10 gigawatt hours per year. And the whole district heating consumption in Europe is around 600 terawatt hours per year. And this is what we took for our estimations about what solar district heating can contribute to the heat supply in Europe. So assuming that there's also future development, district heating development foreseen beyond the 600 terawatt, probably 200 to 300 terawatt hours per year of solar thermal are possible. And this corresponds to very big numbers, so to 400 million square meters of solar thermal collectors. So that's 8 times the installed collector area what we have at the moment. And the added value is quite large in comparison to what is invested at the moment in energy supply in European Union. So only investment in energy supply, not consume of energy, is 40 to 60 billion per year. And the resulting reductions of this measure in all over Europe would be more or less the CO2 emissions what are now from the country of Austria. So LEAD is working on this topic in different feasibility studies and research projects, for example, on storages and on controls and on system design for the whole city. So I go over this briefly because Karina will have soon the microphone. And yes, what can be said is that large-scale solar plants deliver unreliable low heat prices due to economies of scale. Because for a big solar field, you only need also only one pump, one heat exchanger, or several pumps and heat exchangers, but not so many per square meter as for a small plant. And they can have a significant contribution to the decarbonization of district heating. And the solar technology, you can say, is major in the megawatt range, and it's ready for rollout. So it's very good to have all these measures in the SDHp2m project to make it actually happen. Thank you. That was my contribution. Now I hand over the microphone to Karina.
So thank you very much, Moritz. Moritz will have to leave soon. So if there are questions from Moritz, please write them down now. Otherwise, I'll hand over to Karina to conclude, let's say, complete the presentation on about Austria. Thank you.
Okay, thanks, Alessandro, for the introduction to my side. And now I will continue with two topics, and the results of the Austrian side is the special energy planning and some subsidies in Austria. First of all, we are the AAE INTEC, and it's a research institution with two main departments, the thermal energy technologies and hybrid systems, and working on building and retrofit, and also on industry processes and energy systems. So first of all, I will focus of the demo region Styria during the project SDH policy to market. In Styria, we have more than 600 biomass district heating plants, and the capacity ranges from 40 kilowatt to 20,000 kilowatt. And these plants are usually based on solid biomass and are sometimes equipped with fossil boilers for peak demand coverage. And approximately 30 have a solar thermal plant installed. And now we have some current initiatives of special energy planning in Styria. Therefore, we have in the Styrian government a department, it's called Space Planning, and it's doing the legislative work for special energy planning. And they worked out a concept for the area for energy, and they have some important topics they are working. On the one hand, are the political goals for the energy and the climate. Therefore, they develop energy efficient and resource saving structures, or they are working on installations of favorable preconditions for the use of renewables. The second part are some analysis of the existing situations and the future potentials. Therefore, they focus in different projects to generate energy relevant structural data, or to make an opening balance for every community. I will come later to that, and to do some analysis of future potentials concerning the energy efficiency or possible substitutions with renewables. Some other points are also they are working to structure the heat supply and to include some relevant aspects of the mobility sector, as well as they try to develop future strategies in the special energy planning. And the main activities during the project to support these two main topics is, on the one hand, we try to create a working group of experts within the Styrian provincial administrations. And the second part was the development of a methodical approach for local and regional urban energy planning. So the first activity during the SDH Policy to Market project in this sector was the working group. The group includes experts from different fields, from the eco-promotion, from regional or sub-regional special energy planning, or some experts for energy technology, air quality, or environmental protection. And they try to find some possibilities for the use of freely maintained areas for efficient local supply of energy. In Austria, they are called these areas are green zones and agriculture priority zones. And they are possible and suitable to install solar thermal energy plants. The second activity is to include analysis and the modeling to find some suitable areas for the solar thermal plants. And therefore, we had one, it's the first step to get an energetic characterization of the Styrian municipality. And therefore, it was a tabular and cartographic presentation of the energy demand and the greenhouse gas emissions for every community in the Styria and for some parts of the municipality. And they provide the energy demand in megawatt hours per year and the energy or the heat density in megawatt hours per hectare per year. And the figure on the right side shows the structured opening balance, which is made for every community in Styria. And the smaller picture showed a heat density map with the deeper side, it's a high density, and if you see the lighter ones, it's the lower heat density. The second step in the approach was to get the detailed analysis of regional building stock and the district heating. And therefore, we analyzed to get information about the building use category, about the building age, the building's heating system, and also the space heating demand of each building. And the next step was the development of a regional heat density map with this data. So on the one hand, with the status quo refurbishment standard, and on the second part, to get some different renovation scenarios. For example, a scenario for 2050, where you have a reduction of the space heating demand up to 60%, or for example, one ambitious scenario where you have a reduction of space heating demand of around 70%. And the picture shows one is an example of a heat density map for the region of Gleisdorf. It's one community in Styria, and it shows the current situation. The next step is to get the priority areas for district heating. So you have to compare the current heat density with the forecasted heat density of the region, so to provide some strategies for district heating and some extension plans. And these heat density maps have some hotspots, and so you can make an expansion stages and the expansion plan for the priority areas. And the final step is to find the suitable area along the district heating network. And in Austria, it should be some green zones or agriculture zones, maybe you can reserve them for solar thermal plants. And the figure on the right side shows a district heating network with some expansion strategies, and the yellow dots show some possible areas for the solar thermal plants. So another topic beside this energy planning are some subsidies, because they are very important on the one hand to support these high investments and also to support the district heating operators. So I will show you one national subsidy in Austria. It's called Large Solar Thermal Systems. And this subsidy has two parts. On the one hand, it is an investment subsidy up to 45%. And the second part, it's supporting to scientific research. So it's in the running, it helps the district heating operators during the implementation period, and also during the running period, they get support from experts and a monitoring. And this subsidy program started first in 2010, and now we have the 9th call in 2018. The subsidized collector area ranges from 100 square meters to 10,000 square meters, and you can apply in 5 different fields. And there's one field is especially for solar district heating. And these applications for the subsidy program needs also a professional consultation that's mandatory, and it's for the planning stage. For example, these are the subsidized projects from 2010 to 2016, and that's about 261 projects with a total collector area of 93,000. And around 20% of them have submitted a collector over 500 square meters, and only 84 selected for the monitoring and the scientific support. So on the next slide, so we try to find a special subsidy model only concerning a facility check and an on-site analysis to support the operators, the district operators, in the planning stage and in the application stage for such a large solar thermal subsidy. Therefore, it was decided to make a survey to get some information and interest about the district heating operators in integration of solar thermal plants, and also to give them some support for the implementation. This is the questionnaire, and the district heating operators then were offered a pre-visibility study for free. And there were selected 15 district heating operators. They are applied for the studies, and that were around 7 cooperative associations and 8 limited companies, and they were around the region of Styria, like shown in the map below. And this visibility study includes a status quo on-site analysis, a rough dimensionation of the solar thermal plants, and also with some different simulation scenarios, then the yield assessment and the cost calculation of the solar thermal plants, also a profitability calculation, and based on the available subsidies and financing possibilities also, and it were also included to do a sensitivity analysis. And finally, they get the personal consultation and a written project report. So to sum up our results in the Austrian region, we can say that special energy planning also supports investors and decision makers to build up, on the one hand, new district district heating networks or expand some district heating networks, or also try to integrate solar thermal plants. Then the Austrian funding program stimulates the market for a commercial large-scale solar thermal applications. And also the Styrian cost-free consultancy on integration of solar thermal plants supports the knowledge about the practical steps towards the implementation. So thank you for the attention.
Thank you very much, Karina. I think it was very inspiring to see that Styria is doing actually quite a lot on solar district heating. Maybe may I ask you if you know if other regions in Austria are also as active as Styria, or do you, in any case, do you plan to basically, show the good, the best practices of Styria to other regions in Austria in order to spread the word and spread the solar district heating experience?
Yes, we also showed some best practice policies. We made some events during the project, so where some operators or some other communities and representatives of that could join.
Okay. Thank you very much. So the next speaker is Riccardo Battisti from Ambiente Italia. The title of his presentation is "Which Measures for Policies and Market Deployment." I think that's probably the best way to introduce him. Riccardo, the floor is yours.
Okay, thank you, Alessandro, and good afternoon also from my side. So my presentation is aiming at, let's say, showing you a bunch of examples of the policy measures we implemented within our SDHp2m project. First of all, we had 9 regional governments coming from 7 countries within our consortium, let's say. And what I want to show through these examples is really that regional or also local authorities, also smaller authorities like municipalities, do have a role in promoting not only solar district heating, because usually it goes hand in hand with other, let's say, efficient solution. We can call it modern, or we can call it 4th generation district heating. But the key point here is that really it's not only utilities which can play a role, but it's really crucial also the role and the tasks of authorities. And I also try to group these tools and policy measures that these authorities develop in 4 groups, according, of course, to the barriers that these tools are trying to overcome. So I try to focus on the 4 main barriers for a wider deployment of solar district heating. So, of course, financing and economics. Then the issue of areas, which was already introduced by Morris, so finding available areas for installing solar collector. Then, of course, there is the barrier or the issue of the knowledge and awareness. And of course, there is also the competition with other energy sources, which could be renewable or fossils. So I would start from Thuringia in Germany, one of our partner regions, and the topic is, of course, financing and economics here. So they could develop a really favorable support framework for developing solar district heating plants. And I think it's very important to underline that these programs are aiming at really covering the full value chain. So this is not only money for, let's say, installing plants, but also, for instance, for consultancy. So if you look at the first program, Green Invest, of course, it's not only for solar district heating, but also for this. And it gives up to 80% of the money needed for consultancy and feasibility. So most of the times, the feasibility, especially if it's for large projects, it costs quite a good amount of money. And so support in this phase is very welcome. Then there is another program which is specific for solar, but not only solar thermal, both for PV and solar thermal. And this finances the investment cost of the systems up to 25%. But you see here that you have a special financing rate, funding rate for citizen cooperatives. So if you are a citizen cooperative and you want to develop a solar district heating plant, then you can get up to 40%. A revision of this system is planned now for increasing the focus on heat, because honestly, so far it has been used mainly for PV investment. And you see that regarding solar thermal, this is really targeting, let's say, innovative system with a solar fraction higher than 60%. This means that the system should cover more than 60% of the total yearly heat demand of the network by solar. And of course, this would imply, as was stressed before by Carlo and by Moritz, a seasonal storage to store the surplus heat in the summer and use it then in winter when the season, when the heating season starts. Then they have two more programs. One is Klima Invest, and the interesting point about this is that it is targeting municipalities, and so it gives some advice services and also training, for instance, for the technical staff of municipalities, and it finances these activities up to 100%, and they even have a kind of a standard started package, which values around 7,500 euros, and it's supported at 100%. Then they start the brand new program, which was started by the Regional Ministry of Infrastructure. And this is for the development of district heating in general, not only solar, in rural areas. So up to, with cities and villages up to 10,000 inhabitants. And once again, this gives a contribution for developing the network, the world network. So not only the plants for supplying heat. And you see that the funding rate is 35% for companies, but once again, if you're a municipalities, you can get a much higher rate of 65%. So you see that some, or at least many of these programs are really targeting municipalities. Then, of course, the second topic or the second barrier is the areas. And I think a very interesting activity was done by the Hamburg region in our SDHp2m project. So they developed the best practice guide. So Maurice before was kind of listing some possible solutions for finding areas. So what Hamburg did, the Hamburg Institute did in our project, was really to collect best examples of all these possible installation solutions. So you can start, of course, from roof areas where you already have an occupied surface, commercial and industrial, and this is usually enough when you go to plants with size of 1,000 to 2,000 square meters. Then you can use infrastructures. So for instance, sewage water basins. You can use, of course, solar to even recover polluted or contaminated areas. Most of us maybe are familiar with PV solutions along traffic routes, so PV noise barriers, but of course this can be done, and this has already been done also with solar thermal, so it's important to keep it in mind. And of course also agricultural areas. So of course in this guide you can find also a lot of of pictures. Some of these plans have been realized, some of them are just rendering, let's say. So you see, for instance, on the bottom left, you see this possible double use of an agricultural land, where even though you installed solar thermal collectors, you can still grow vegetables in a kind of solar greenhouse. Also, of course, the Hamburg Institute developed, together with this best practice guide, policy recommendation on how to facilitate the implementation. So how to, facilitate the use of this area. For instance, regarding roof, commercial roof, you can have building codes obliging developers of these buildings to allow the future use of solar heat. This has been done in a lot of building codes in the cities, for instance, regarding residential applications. But maybe for the commercial is quite an innovative solution. Then regarding the use of contaminated areas, of course, you can ask for simplification of the legal procedures. While I think this was also shown already by Karina, very practical example. So you have regional development plans. There are some, let's say, second level agricultural areas that are of course close to the district heating networks, so the heat losses are not that high, and you can secure this land for the future use of solar district heating. And as Karina already showed in details, Styria also in Austria is working on spatial planning on this specific topic. Then I go to the third barrier, which is knowledge and awareness. So how to overcome this lack of knowledge and awareness. From a technical point of view, I think this is a very nice example, again, from Torino Germany. They developed a web-based tool, which is called Solar Calculator. And you can use this tool. You see, you have a map. You can draw an area, which could be both on the roof or on the ground. And then you have an estimation of the yield, so of the energy produced over 1 year from this plant, either photovoltaic or solar thermal, and you can have also a sort of simplified economic calculation. So it's a very quick tool for a first feasibility assessment that it tells you immediately whether your idea makes sense or not, let's say. Of course, then you would need a more detailed feasibility, but it's a very interesting tool to overcome the first problem of technical knowledge. Then this, I think, will be shown also by Alexis. So just maybe a few words on that. So the region of Auvergne-Rhône-Alpes, which was another one of the SDHp2m project partners, developed a video. And the interesting point of this video is that even though it also contains technical explanation, it is mainly targeting local authorities and regional councils. So I think this is in line with what Alessandro was asking Karina. So how do you spread then the best practice from one region to the other? So for instance, in France, they chose the idea of the video. You see also that from the point of view of cost, it's quite low. So with 15,000 euro, you have something which can be used over and over again. By the way, it also has English subtitles. So any of you or any of us can use also this video as a promotion. But maybe Alexis will tell more about that. Coming to knowledge and awareness, again, from a technical, targeting technical, let's say, audience, in this case, utilities. You already saw this example from Karina of the feasibility studies offered for free to the already existing biomass district heating operators. Maybe I just want to underline, I don't want to repeat, of course, the process already explained by Karina, but I want to underline 2 points. The first is that this survey was possible because they already had a database. So to keep records of the plants is very important, because then you know which sectors you can address, let's say. And the second point is that, once again, as I already show you in Thuringia, economical support, in this case, it was a consultancy offered for free. Economical support is needed not only in the realization phase, in the installation phase, in the investment phase, but also during the feasibility. And for small operators, even a feasibility study with a cost of 2,000–3,000 euros can be anyway a barrier. So if in this case it was paid partially by the project and by the government, and so it was a very nice way to overcome these initial barriers. Then coming to the last point, because actually the example of Styria is also related to the competition with other energy sources, because they asked for solar to replace biomass, basically. I want to show you an example from my own country, from Italy, and in particular from the region of Veneto. We had, and we are still having, by the way, a very good cooperation with the Italian Biomass Association, which is called AIEL. We developed together some common dissemination workshops within the project. I could write an article on AIEL newsletter stressing the benefits of integrating solar into biomass district heating networks. We developed a feasibility study for solar integration into an existing biomass district heating network, which has a size which is, let's say, quite typical of the north of Italy. So it's very interesting because it could be highly replicable. And then another interesting point is that this AIEL association has a very well established training activity for professionals, and we were allowed, let's say, to jump in also with our SDH module, so 1.5 hours on SDH. So we could train, let's say, these biomass people to have in mind also the opportunity that it could be not only biomass, but biomass plus solar. And then, of course, we are still doing some common lobbying activities towards region, for instance, for developing tenders or on how to use the existing funding for developing small networks in rural area. And I think all this activity can be summarized through this sentence, which was spelled out by IL technical director in one of our common workshop. Burning biomass in summer just does not make sense. We should use solar thermal instead. And this was exactly before my speech on solar district heating. So it was very nice to see that the best, let's say, SDH promoter was actually coming from the biomass side and not from the solar thermal side. So the main message here is really that we should look at this. Okay, it is a barrier, it could be a barrier, but we should not look at other renewable energy sources as competitors, but rather as a potential alliance, because especially in the approach of fourth generation district heating, where you use several sources depending on the market and on the climate conditions, I think it is very important not to exclude any of these sources. So my conclusions are just completely identical to the introduction. So I hope I showed you how our regional governments really could develop very concrete tools, concrete measures to have an active role in promoting this kind of modern district heating. And once again, I just want to remind you which are these four main barriers, or we can put it in a positive way. So the four areas where you can develop policy measures: financing and economics, the question of how to find available areas for placing solar collectors, how to raise knowledge and awareness towards technical people, but also, of course, towards policymakers, and how to, let's say, establish a competition, or rather an alliance with other sources. And just one last point, it is very important to have, of course, direct testimonies of policymakers, which are really SDH champions, SDH supporters, and that's why in our project leaflet, we wanted to have these testimonies from the three main regions, Styria, Thuringia, and Auvergne-Rhône-Alpes in our project. So thank you for the attention. And of course, if you want to know more about these policy measures we developed, these were just some of the examples. You can also write me an email. Thank you.
Thank you very much, Ricardo. So I invite you to write questions for him if there are. In the meantime, we noticed that there is a question for Karina about the subsidies. What is the planning of the situations for subsidies in 2019? If there are going to be subsidies, what if the situation is going to evolve, and in which way? Karina, I don't know if you are able to reply. Yeah.
Yes, I was talking about the program for large solar thermal plants, and now therefore is the ninth call is open. So some district heating operators can apply for this subsidy, and this is working out in the next year, so in the period 2019. And they're also planning to keep this subsidy program online. So
okay. Yeah. So thank you very much. I think it's quite clear. So our last speaker is Alexis Peya from the Regional Council of Auvergne-Rhône-Alpes, and he will talk about his own experience from the side of the province, and also more in general about the results for France. Thank you, Alexis. You can. The floor is yours.
Yes, thank you, Alessandro. And first of all, thanks for giving me the opportunity to present some facts on Auvergne-Rhône-Alpes. And first of all, I want to say that the region Auvergne-Rhône-Alpes was in this project as an affiliated partner with the Regional Energy Agency, which is Auvergne-Rhône-Alpes Énergie Environnement, which you can see the logo here, and of course with technical experts from Saadat, Ines, which were involved in the project as well. So the interesting point, which has been outlined by Carl or Ricardo as well, was that we were in as local authorities, and it was more simple to make the link between like technical aspects and political aspects. And it's true, it was really important. For instance, that our vice president, which was Eric Fournier, you've seen on the picture in Ricardo's presentation, was there in the project and was here to spread good information on SDH. So I think it's really a nice point. So I'm gonna make a presentation on some points and activities in Auvergne-Rhône-Alpes. First of all, a short introduction on regional context and SDH in France, which will be quite quick. And afterwards, just two points which will just focus on framework improvement, which has been what have been made during this project, and then mobilization of project investments, which actions has been made as well. So you can follow this agenda during my presentation on the top. First of all, I just wanted to present you this picture. You've seen a similar picture during Carlo's presentation. But in this map, you've got less points for the moment. I hope there will be much more in the coming years. The aim of this map is to show you which main project we've got in France about SDH. What you can see that there is mainly, let's say, small size projects. And because the biggest one is 2,300 square meters in Chateaubriand. And in the region, we've got more smaller projects at the moment, and we've got several projects in development, like in just at the project phase. But the main point about SDH projects is you'll see in the barriers is that it's difficult to at the moment to develop really like big size project at the moment. And just a short word about the biggest one in France, which is Chateaubriand. I just wanted to show you a little picture of that because it's an interesting thing to see that to be able to develop this size of project, the attention has been focused on finding a good area to put the panels, and the panels were just installed on a specific area where there were no other construction were possible because there were a flooding area and some risk of flooding, and that's why they decided to use this specific area to put solar panels. And there have just been some adaptation of the structures to be able to, yes, it's a bit higher just to avoid to be that the panels will be in the water. But I think it's really a nice project to see that even if it can be difficult to find suitable areas to develop projects, you can find like innovative solutions to be able to develop projects. So that's the main point. So as I said, it's 2,300 square meters with double glazed flat panels, and you've got a little bit of storage. You can see on the right pictures, you've got 3 storage tanks. So what's interesting is that you've got a cover rate of 8%, and it's really a network working with wood cogeneration gas. So it's a nice project, and we hope that we will have similar project in the region soon. So I'm gonna talk now more about specific activities in the region. And so in order to be able to talk about that, I just wanted to present you the region. Maybe some of you don't know where is Auvergne-Rhône-Alpes and what's its size, etc. So here you see a map of the region. It's quite a big region in France. It's like 13% of France area, and it's 67% of mountain, or let's say not specific mountain, but high area at least. and it's more than 7 million of inhabitants, and so it's 12% of French population, and 70 and almost 80% of population is living in urban area, and that's quite interesting for district heating, because we've got quite a, you'll see just after, we've got quite a lot of district heating, and it's good opportunity to try to spread like solar thermal in those district heating. And in terms of economics, you see the GDP just below 230, and it's like approximately the same share of area. It's 12%, and it's the 8th European region. So it's a new region because in 2016, two different region has been made in just one. So it's really a new nice area to try to develop new projects. So here's, the context. Now let's go into the specific activities we've made during the project. So yeah, first point, as I said, framework improvement. That was different action made to try to improve all the framework around SDH. As a prelude, let's say, and it can interest other cities, we try to involve people in SDH. I think the key point was to associate all regional stakeholder in an advisory group. As our vice president say in the small quote you see on the Ricardo presentation, I think the fact of knowing what our stakeholders need to what were the main barriers and what we need to develop to help them was really really necessary to try to go a step further in SDH development. So we try to associate like association, policymakers, DHC operators, municipalities, financial institutions, and suppliers to implique them in this project. And so we had 4 meetings and 1 delegation travel. And I think it's a really good means of like starting something and having a good development phase. So after all this like good advisory group, we could like implement some actions to try to improve our framework in the region. First was the link with positive energy territory schemes. Its territory we call TPOS, and I just gonna make a focus just after. Second point was improve access to financing. This point was as it has been said before, trying to give subsidies for feasibility studies, because it's not like simple for a project. People wanted to develop project to being able to finance those studies. So it's really a point which was important for us, like giving subsidies for these studies. And complementary, we try and we spread a specific template which with all technical specification inside, and it was like something to help people to know, if you want to do a study on SDH, here are the guidelines you have to follow to do it good. So it was important to do this work. And afterwards, we also create subsidies from the Regional Council of Rhone-Rhône-Alpes to finance SDH, and the main point here was to complement the national subsidy scheme from ADEME. So it was the main issues was to be complementary. And finally, we made some capacity building with local authorities, and that was really important because we made some study cases, and to be able that study case were useful, we made some capacity buildings in parallel to be able to explain what SDH was and how it works and why is it so interesting. So just a small focus on TPOS, as I said. So in the region, we've got like more than almost 40 territories you can see on the map. which are engaged in a process we called TPOS, and TPOS is like 100% renewable energy sources territory. Their aim is to produce enough renewable energy to meet their need by 2050. So it's quite a big ambition. And what's interesting that we can just rely on those territories to try to develop new SDH projects, because they need to reach this objective of 100% renewable energy sources, so they need solar thermal. So our job were to say, you want to be TPOS in 2050, we give you a solution, a technical solution that can help you to reach that goal. So we made a lot of information to those territories, and I think in different countries, it's a really good means to rely on those local authorities, which are really which has good ambitions to be able to develop new project. I think it's a really good point. So we had 5 TPOS involved in the project, and I think we could go on with this animation and go for more project with them. So afterwards, I wanted to talk on the second part. We had a lot of action to try to improve the general frameworks, and afterwards we wanted to try to do some other actions to try to mobilize new project and investments. And in these parts, I will just give you in this slide a general overview, and afterwards I will just focus on case studies and market study we've made in the region with more detailed figures. So what did we do for supporting market rollout? We made capacity building for market actors. You can see on the picture on the right, we made a 2-day training in June 2018. And we had more than 30 participants. And what's interesting is that it's not like one-shot training, because it has been made in June, but it will be made each year, because we had a partnership with a national French environment agency called ADEME, and it's now we are sure that each year we're gonna have these 2 days training. So it's really a good point, because when we had the first meeting, we noticed that design offices or energy suppliers were not really didn't have the knowledge about SDH, so it's really a strong barrier to overcome. And I think this type of action, like relying on local experts or international experts, because some coaches within SDHp2m project help us to do this training. I think it's really important to be able to spread good information on SDH in a really technical training. The second point was improve public acceptance, and more widely than public acceptance, we developed also tool like a video and a toolbox online to be able to have information available and simple to find and simple to understand. So that will be a specific focus afterwards, but you can see just on the bottom of the slide, we had a different document which has been made and which has been really well organized and put on a website, and it's available for everybody. And we had as well a SDH Advice Center, which was active. That is to say, if we had local authorities which had question about SDH, they could just call our experts in the region to have information and help them to see if they need to do feasibility studies and if it's interesting for their case. After that, we had made 3 case studies really specific at the region and a market study. So we just explain it in detail just after. And we had a new calculation tools. We've seen on other presentation, you can have a map with tools to calculate SDH. The tool which will be developed in the region will be really a technical tools for design offices, and to have really a strong and a really correct tool for every design office to design SDH. The goal of all these measures were to improve the supply, having a strong supply and a demand for SDH. What can be interesting for other other cities is the market study we've made, because it was really simple one, but I think it can be effective. In the region, we've got 186 DHC, but only one SDH which is already constructed. You see like the amount of energy which is supplied, and in the region we've got 58% of renewable energy sources, including waste incinerator heat. And what we can see is that 20 biggest DHC, it's 75% of its supply. So we see that we've got quite a lot of DHC, so quite a huge potential, but we could not say if it's really like feasible on all these DHC or only on a part of them. And that's why we made a really simple scenario. And scenario was to say, well, we want to integrate solar thermal in those grids, and we take 3 pessimistic hypotheses, and which were no solar thermal integration in DHC with waste incinerator heat, replacement of fossil energy only, new biomass substitution, and no more than 15% of solar thermal in the global district heating energy mix. And what's really interesting that the results were that 132 DHC out of 186 can integrate a part of solar thermal energy. So it's 70%. And we can see that we add pessimistic hypothesis and 70% of DHC that can integrate. And it will be like more than 500,000 square meter of panels. So it's really a nice opportunity to go. And we see that we have a real potential on small biomass to remove fossil fuel energy during the summer. And I think it's simple to replicate in other cities or region. If you've got a good knowledge of your DHC, you can simply like identify where you can go and what will be your aim. And finally, just want to focus on a point we made on regional case, but I'm going to be quick. I said I spent a bit more time than expected. We had 3 case studies during SDHp2m project on 3 different projects. One in Chambéry, one in Clermont-Ferrand, one in Pélussin. It was different size of DHC, and it was also different type of energy in the DHC. So what we can see is that we just tested different scenario, and with a solar fraction from 2% up to 10% with or without storage. And we learned quite a lot. And first lesson was the impact of return temperature on solar installation. We made a sensibility studies on one case, which was Chambéry. And we see that if we just lowering the return temperature from 80 to 70 degrees, we could like gain more than 10% on solar productivity. And we can gain like 10% on solar heat costs. And it was even more if we went from 70 to 60. It was really a nice gain. And what's nice to see is that working on integrating solar thermal can help you to have a reflection on how your district heating works and improve its whole functioning. So it's really nice. And the general conclusion of this study case were that the heat cost without subsidy was around 120 euro per megawatt hour, and if you with subsidies, it was 40 euros per megawatt hour, which was really interesting. And we see, and it has been said in the presentation before, you've got a huge impact of temperature, you've got a huge impact on summer heat needs, and of course the barriers, it's areas. You've got to find suitables and areas to install the panels, plant size, and solar thermal panel technology. So it's, let's say, the main conclusions to be quick, but it's, I think, interesting when you are thinking about developing SDH in your region or in your cities to look at 1 or 2 typical cases and try to develop adapted configuration for SDH for your region or city. And in Auvergne-Rhône-Alpes, we saw that we had a real potential on small biomass THC to remove fossil fuel during the summer. So I think it's a huge and interesting thing we are going to do more for further projects.
Okay, thank you, Alexis. I think can you conclude?
Yes.
Like, thank you.
Yes, I'm concluding. Sorry. So yeah, I'm just going to the last slide, which was solar. I think is necessary. I think we're gonna have new projects soon, and I think we can use as well financial tool like regional fund or a citizen fund that can be really a good help for further project. And last but not least, just a link for the video. Just Ricardo told about, and you can just click on the video to see that. It's in French, but don't worry, there are English subtitles, and you think everything you ever wanted to know about SDH is inside. Thanks a lot.
Okay, thank you very much, Alexis. So we have one question for Ricardo. Ricardo, there seems to be a subsidy-driven wave of new solar thermal projects in Italy, and that seems to be almost gone now. Then who is aiming to go solar district heating in Italy now? Greenhouses, breweries, municipalities, others? So that's the first question for Ricardo.
Yes, I think there are two, let's say, I would say completely different markets. I mean, the integration of SDH in existing grids, I think this is still interesting. There is a national incentive scheme which is able to cover between 50% and 65% of the investment. So it's interesting for the utilities, and at the moment we carried out some feasibility studies for also for large utilities which are aiming at starting introducing, let's say, solar thermal. And this is one market which I think is, I mean, the economic conditions are not bad. Maybe one barrier is that usually when they have cogeneration units and they use natural gas to drive these cogeneration units, they have a very low price for this gas because they have a reduced tax on this gas. So the competition in this case with other energy sources is very tough, but the conditions are, I would say, quite positive because of this support scheme we have. And then you can have the development of new district heating networks. So I'm especially thinking about, let's say, smaller cities up to 10,000 inhabitants. In this case, of course, the network should be really renewable. So it could be biomass plus solar. And you can have even this incentive of the conto termico for both biomass and solar. So I think this could be also very interesting. The problem in this case is to find a suitable developer, because usually the Italian utilities are used to larger networks, let's say, and there are not so many specialized actors which want to develop such new infrastructure. I don't know if I replied exactly to the question, but this is more or less the situation.
Okay, thank you. Then we have another question that I think is a bit more open, maybe to you, Ricardo, for Alexis as well. Generally, are investors you're talking to more asking for payback time or internal rate of return or levelized cost of heating, cost stabilization, etc.? Which are the criteria that investors are looking? I don't know if this can be maybe for Ricardo, for Alexis. Ricardo, you want to try?
Yes, I can start. Of course, it depends on the investor. What I always say, it could sound a big a provocation, but usually it really depends on their time horizon. I mean, I realize that payback time in Denmark are usually not shorter than in Italy. So we have maybe higher grid temperatures, but they have less solar radiation. So more or less these effects are compensating. The point is that for them, maybe a payback time of 20 years is not high, is not a long time, because they think that if you build an infrastructure then you should at least think with a 20-25 year horizon. But I must say, from my experience, the payback time is usually what they are asking for.
Mm.
I think Karina, maybe, or Alexis, is anyone who wants to add something? Otherwise, I think we are going toward the conclusion.
I think in Austria it's the same. It's the payback time is one of the main topics.
Okay. Okay. Then I'll thank you all very much. Thank you for that to the attendees. Thank you to the speakers. The recording will be available in the next days. And again, it was a very pleasant webinar, and I wish you a very nice afternoon. And see you soon. Thank you.